So now we'll cover the most interesting of the, in principle, what should be the MM groups, the 3M. And you're going to see that there is no extra unique plane here, and we'll talk about that in a second. So in this case, we need to look at the threefold axis combined with the mirror plane. Now at first, let's do a little homework over here on the side. If I take a threefold axis and I combine it with a mirror plane, see, the tricky thing is that this is not symmetric about the zero like the hexagonal. So in other words, if you strictly look at rotation, they come from these three angles only in a threefold axis, right? And they don't penetrate across, right? But of course, if I, if I put a mirror plane in there, then automatically I reflect things. So for example, if I put a sigma 1 through here, what I'm going to do is reflect this guy across this way. And if I put a mirror plane through here, I'm going to reflect everything across that plane. If I put sigma 1, I'm going to put a mirror plane there and reflect everything across that way, right? So if I put in these three mirror planes that are going to satisfy the threefold reflection, I can't just have these mirror planes. They're going to have to pass through the origin and be an entire plane. They can't stop in the center, right? So, because it has to go, through the entire point group. And so I end up with, sigma 2, sigma 3. Obviously, these are all connected because they are just rotated with respect to each other, right? So in a way, what the threefold axis does, because it's a threefold axis and a plane in 2D is a line, you kind of get these angles here on your own just from these combinations, right? So even though the original angle in the red is 120 degrees, the symmetry of the threefold axis induces 60 degrees anyway. And that's going to be very important because here I have my 120 degrees. Remember what our theorem says. Our theorem says, well, half of that angle is where I find the sigma, right? So, here, if I'm looking for, let's pick blue now, and I use sigma 1 for my theorem instead of the gray, which is induced just from the symmetry of the threefold axis. You can see already what's going to happen, because sigma 1 says, oh, pi over 3 away, which is 60 degrees, I have another plane, sigma 2. So you would think sigma 2 would be the unique blue one. I shouldn't use blue over here really, but I'm trying to show that we're using this theorem now. So this should be the unique one, but it actually overlaps with gray that was already there just from the rotation. So what you realize is that this theorem now doesn't produce a unique symmetry element, because the combination of these two already creates, right, the symmetry elements where I have this guy with this guy with this guy and with this guy. And so that symmetry is induced just with rotation and mirror plane. And all this theorem does is lie other planes on already existing planes. And so no unique mirror planes are induced. And so, in this particular case, we write 3-fold plus the mirror plane, and there is no unique other mirror plane induced.